Welcome to the 14th video in the Metric Math Water Wastewater YouTube series. This video is going to focus on determining what pressure is in a liquid, how pressure can be calculated at a specific depth, and what are some of the factors which can affect the pressure at any point in that depth. The question that we're looking at today reads, a round tank measures 11.7 meters in diameter, 7.5 meters in height, and it's filled to the top with clean water. Find the pressure in kilopascals at the bottom of the tank. Now, when we take a look at this information, there's a number of things you have to pick up on to get a better probability of solving the question. The first thing you have to recognize is, what is pressure? Well, pressure is a force over an area. In the American-British measurement system, the unit for pressure is PSI, pounds force per square inch. We're dealing with a metric system, so we're dealing in kilopascals. But again, we look at the whole concept of how much force from above is pushing down on a surface, again, due to gravity. In this particular question, we notice that the column of water is 7.5 meters in height. Now, we're not sure at this point in time where we're doing the measurement. Is it at the bottom? Is it at the middle? Is it at the top? We have to identify that. Another thing that we have picked up on is it's filled to the very top with clean water. Just because the tank is 7.5 meters in height doesn't necessarily mean that the water is right to the top or halfway or three-quarter or whatever. And notice it's clean water. There's nothing dissolved into it that's going to change its density or its specific gravity. If we also take a look at the information, we notice that the diameter is 11.7 meters in size. Now, this really is a distractor. And the reason why it's a distractor is we don't care about the water beside, because gravity can't affect sideways. It can only affect down. So this is a complete misnomer. It's a distractor. And so what do we do with those? We just rule them out. We completely ignore them. What is the unit that we're looking for? Well, the question says that it's in kilopascals. And notice the point of being measured. It's at the bottom of the tank. That's important, because that tells you how much water is above the measuring point. In this case, it's 7.5 meters above the measuring point. Now, let's take a look at a handy little method of putting all this information in a logical sequence. Let's draw a diagram. So here we can see the cylinder, and notice the height of the tank is 7.5 meters, but we're not concerned so much about that as we're concerned about what's the height of the column of water above the measuring point. It's at the bottom of the tank. That's where the measurement takes place. So we know that there's 7.5 meters of water above that. Once we have that taken care of, now we can fill in the formula. So let's again refer to the diagram. We're concerned with the height of the water column above the measuring point. And so the formula is the column of water height in meters above the measuring point, multiplied by 9.81 kilopascals for each meter. And then there's another factor called specific gravity. And for us, this is a nice, easy number because it's clean water. That number is 1. So we don't even have to really worry about that at all. Let's plug the numbers in. So that's 7.5 meters of water above the measuring point, multiplied by 9.81 kilopascals for each meter. And because the specific gravity is 1, we just don't even worry about that. The answer, when you multiply those out, is 73.58 kilopascals. Now, here's a handy little mental estimate. 9.81 is almost 10. A little bit less than that, but it's pretty close. So whatever we take as the height of the water column above the measuring point, multiply that by 10, and that gives us a pretty quick mental estimate as to what the answer should be. So yeah, it should be a little bit less than 75 kilopascals. Now we take a look, is the unit correct? The answer that we got was 73.58, and the question demanded that the pressure be in kilopascals. Now, I mentioned earlier that the imperial unit is pounds per square inch, but there's some other options for measuring. It could be in atmospheres, it could be in millimeters of mercury, it could be in bars. There's a variety of options there, but we are going to be using the metric system, so we're going to stick with 73.58. There's some variations off of this to kind of end off the video. Well, what happens if you're given the pressure and you don't know what the height is? Well, here's a handy little pi solution. Notice on the top, pressure is equal to the bottom two multiplied together, 9.81 times the column height in meters. What happens if the height is unknown? Well, the pressure is on top, and think of that horizontal line as a dividing line. So pressure in kilopascals divided by 9.81 will get you the correct answer. Now, what happens if the fluid is something other than water, that has a specific gravity other than water? Well, here is where you put that number in at the end. If the specific gravity, some call it the density, which is pretty close. If the density is higher than 1, well, you're going to need more pressure because there's more weight pulling down. For example, if the specific gravity is 2, then the pressure will be twice as high. If the specific gravity is less than 1, then there's going to be less pressure pushing down on the source. That's it for today. Thanks for watching this math video. Please check out the other videos in this channel, put in some comments, pass this site on to other water or wastewater students that are working on their math. Goodbye for now, and have a good day.